Hello everyone, myself P. Jithendar, Assistant Professor in Electrical and Electronics Engineering, MLR Institute of Technology. In today's video session, I am going to discuss about the electrical machines. So in this electrical machines, we are having the two parts here. One is the DC machine, another one is AC machine. Okay. So here we have to discuss about the construction and working principle of DC motor. So here in electrical machines, we are having the mainly two parts here. So this is electrical machines which consisting of two parts. One is DC machine, another one is AC machine. So here in DC machine, we are talk about the DC motor as well as the DC generator. This is in DC machine. In AC machine, so we have to talk about the transformer. So single phase transformer and induction motor. So that is three phase induction motor. So these topics will discussed in the electrical machines. Okay. So electrical machines consisting of the two parts here. One is DC machine, another one is AC machine. So the DC machine consisting of the DC motor and DC generator, and for the AC machine which consisting of the transformer and three phase induction motor. Okay. So now in today's video session, we are going to discuss about the construction and working principle of DC motor. Okay. So we need to discuss about the construction and working principle of DC motor. Okay. So here the working principle of DC motor is, so here mainly we have to discuss about the conversion. So here the first point we have to discuss about the conversion. What is the conversion of DC motor? So the conversion of DC motor which converts electrical energy into mechanical energy. The conversion of DC motor is which converts electrical energy into mechanical energy. So if you are give the input as a electrical supply, so the output side will get the mechanical power or output voltage and output current, right? So here is the conversion of the DC motor. And principle. So what is the principle? The principle of DC motor. So here the principle of DC motor is, so here when a current carrying conductor placed in a magnetic field, the mechanical force is experienced by the conductor. That is according to Fleming's left hand rule. That is the principle of DC motor. Okay. When a current carrying conductor placed in a magnetic field, the mechanical force is experienced by the conductor. According to Fleming's left hand rule is the principle of DC motor. Okay. So now construction. So what is the construction of a DC motor? So here we are having the construction. So construction of DC motor. So here for this construction of a DC motor, so I am taking the one diagram here. So which is consisting of two permanent magnets. So here we are having the two permanent magnets. One is North Pole, another one is South Pole. Means we are having the two poles here. So in between two permanent magnets, we need to place one copper coil here. So we need to place one copper coil. So here is the copper coil. The end of this coil, we have to connect one commutator. So here the function of the commutator is to collect current from the coil. Okay. And for this commutator having the brushes. So here is the brushes. For these two brushes, we need to give the DC supply. So plus minus voltage is V. So here what is the function of the brushes? So brushes is represented as a B1 and this is B2, right? So the function of brushes is to collect current from the commutator. Okay, this is the simple construction of a DC motor. Okay, so now working. So what is the working of DC motor, right? So here, so we are taking the two permanent magnets, the which is North Pole and South Pole. In between North Pole and South Pole, we are placing one coil here, one copper coil here. The end of this copper coil connected is, the end of this copper coil is connected to the commutator. For this commutator having the two brushes, that is B1 and B2. And for this B1 and B2, we need to give the DC supply, right? Now working, what is the working of DC motor, right? So we are giving the DC supply here. So when we are giving the DC supply, the electrical current is passes from the positive terminal. So here, so like this, the current is passing from the positive terminal to brush B1, commutator and copper coil. So like this, the electrical current is flowing up to, and it finally it will be reached to the negative terminal, right? If you are giving the DC supply, the electrical current is passes from the positive terminal to brush B1, commutator and copper coil and brush B2, and finally it will be reached to the negative terminal, right? So in that case, due to the reaction between this permanent magnet, so this is permanent magnet. So due to the reaction between this permanent magnet and copper coil, some amount of flux will be induced from the north pole to south pole. So due to the reaction between the permanent magnet and copper coil, some amount of flux will be induced. So here the flux will be induced from the north pole to south pole, right? So here is the flux. So if the flux is induced, means automatically the coil will start rotate. If the coil is start rotate, means we'll get the output power, output current and torque. We'll get the output power, output current and torque. Okay, here is the working of DC motor. Okay, so when we are giving the DC supply, the electrical current is passes from the positive terminal to brush B1, commutator, coil and brush B2, and finally it will be reached to the negative terminal. So if the current is passes through this copper coil, due to the reaction between the permanent magnet and copper coil, some amount of flux will be induced from the north pole to south pole. So in that case, automatically the coil will start rotate. If the coil is start rotate, means we will get the output power, output current and torque of the DC motor. Okay, here is the construction of a DC motor. Similarly, we are having the DC generator. So for this we are having the DC generator. So for this DC generator, so here also the first point is conversion. So the conversion of DC generator is which converts mechanical energy into electrical energy, which converts mechanical energy into electrical energy. Here input as a, so mechanically we have to give the input and output side will get the electrically will get the output here, right? So the main conversion of DC generator is which converts mechanical energy into electrical energy. And next point is principle. What is the principle of DC generator? The principle of the DC generator is when a conductor cuts the magnetic field, the EMF will be induced. That is according to Faraday's law. That is according to Faraday's law of electromagnetic induction. So according to Faraday's law, the EMF equation is equal to N into d phi divided by dt is the EMF equation. So in this case, N is nothing but number of turns, d phi is change in flux, and dt is change in time. Okay, here is the principle of the DC generator. Now in this case also we are having the construction. So here in the construction point of view, there is no difference between the DC motor as well as the DC generator. Only difference is, for the DC motor we need to give the DC supply. Now for the DC generator, in the place of DC supply we have to connect a load. So here we are having the diagram. So again, having the two permanent magnets, north pole and south pole. In between these two permanent magnets, we need to connect one copper coil. So here is the copper coil, and here commutator is there. For this commutator we are having the two brushes. For these two brushes we need to give the load, and this is load. So how we can run this DC generator? By using the prime mover. Okay, by using the prime mover we have to run the DC generator. If we can run the DC generator, we'll get output power, output current across the load resistor RL, or we'll get the generated EMF or generated voltage and current, and also we'll get the power, that is output power across the load resistor RL. Okay, here is the difference between the motor and generator. For this motor we are giving the DC supply, and for this generator we are giving the load in the place of DC supply. Okay, here is about the motor and generator. So here the first point is, so for the motor the conversion is, which converts electrical energy into mechanical energy, is the conversion of DC motor. And the principle of DC motor is, when a current carrying conductor placed in a magnetic field, the mechanical force is experienced by the conductor, is the principle of DC motor. And here is the construction of a simple construction of a DC motor here, right? And for the DC generator, the conversion of DC generator is, which converts mechanical energy into electrical energy. And principle is, when a conductor cuts the magnetic field, the EMF will be induced. That is according to Faraday's law of electromagnetic induction. So according to Faraday's law, the EMF equation is E equal to N into d phi divided by dt. Now what is d phi here? Change in flux. What is dt? Change in time. And N is total number of turns here. Now this is the total construction of a DC generator. So across this load resistor we'll get the generated EMF and output current and output power. So this is about the DC motor and DC generator. Okay, so in next class we are going to discuss about the construction of a DC machine as well as the EMF equation of a DC generator. Okay, so thank you one and all.